All right, guys, so let's just go over the practice quiz that I gave you. Just a couple of reminders. This is the equation for Hardy-Weinberg is p squared plus 2pq plus q squared equals 1. Where p squared, it's the frequency of the homozygous dominant genotypes. Because it is squared, it has two alleles. It's A in this case is both capitals, that's why it's square. Q squared is the frequency of the homozygous recessive genotype. 2pq, it's the heterozygous. And then the P is the frequency of the dominant allele, and Q, it's the frequency of the recessive allele. Just notice that they have single letters, so they are just single letters here. But once they have two letters, they have the square or the 2, okay? And all frequencies gotta be expressed in decimals. All right, so the first question deals with the population of Arctic foxes. And in this case, I told you that 49% of that population has black paws. And then the problem with this is that black is dominant over white. So for you to have, and I keep on doing that. All right, now that's fixed. So 49% is black, but that means that they can be either homozygous dominant or they can be heterozygous. That is why I cannot use the 49% because I don't know if that means homozygous dominant or heterozygous. So I'm going to use the recessive, which in this case is 51%, and that means they have white paws, and because they're showing the recessive phenotype, that means that they must be homozygous recessive. So now I know my first variable, which is q squared, and I'm going to express that 51 as a decimal. So q squared is now 0.51, and I got my first variable solved. Once I have q squared, it's easy to find q because all I have to do is get the square root of that. So now I figure out that q is 0. Oops, let me go back. Q is 0.70. It's supposed to be 0.714, but don't worry, just keep it at 70. So now I have q. Once I know q, I definitely know p, because p plus q equals 1, which means that p must be 1 minus q. So p must be 0.3. I got p solved. Once I got p, it's a breeze to get p squared. All I have to do is multiply 7.3 times 0.3, and p squared is now 0.09. Got my third variable there, and my final variable, my fourth variable. And my final fifth variable is 2pq, and all I have to do is plug in the numbers. So p is 0.3, and q is 0.7, and now 2pq is 0.42. But that's not what the problems ask. I ask you for specific things. So letter A, I was asking you for the percentage of the population that is homozygous dominant. So that will be p squared, and since p squared is 0.9, that means that the population that has homozygous dominant is 9%. So 9% is B. Letter B, I was asking you for the percentage of the population that is homozygous recessive. That will be q squared. I already gave it to you at the beginning of the problem. So that is 51% of the population is homozygous recessive. Then the percentage of the population that is heterozygous, that will be 2pq. So that will be 42%, which is heterozygous. Then I ask for the frequency of the dominant allele. So what is p? So in this case is 0.3. That will be the dominant allele. And finally, 0.7 will be the frequency of the recessive allele. All right. The second problem had to deal with a gecko that it's endemic to the island of Mauritius. And in this case, it has a variation which it could be white, red, blue, or black, and it was found that the blue coloration is recessive, and the percentage of the allele, now I'm talking about allele, is 9% of the recessive allele. So that tells that B is 9%, which means that Q is 9, and that will be 0.09. So now we got Q. Don't worry about whether the white or the red or the black is dominant. It doesn't matter. We're just trying to figure it out. So now we know that Q is 0.09, which means we can easily figure out Q squared by multiplying that on its own. So that will give us 0.081. That will be Q squared. P again is 1 minus Q. That will give us 0.91. P squared, all I have to do is 0.91 times 0.91, and that will give me 0.83. And then I just have to plug those numbers into the 2PQ, and now I find out that that is 0.16. So again, the questions were, what is the percentage of the population that is homozygous dominant? That will be P squared. So 83% of the population carries the dominant trait, whether it is black or white or red, who cares? Then only 0.8% of the population has the recessive allele. In this case, if you find a blue gecko, you are lucky because they're not so common. Finally, oops, this is not working again. My stylus decided to die on me. Oh, there you go. Sorry. The heterozygous will be 16%. The frequency of the dominant allele is 0.91, and the frequency of the recessive allele is 0.09. So that gives us the answer. All right, third question. The population. This is a little tricky because I'm telling you number of individuals. So first you have to calculate what is the total population, which in this case is 549. Now, I give you the number of individuals that have the black beaks, which is dominant over yellow, and I give you the number of individuals that have the yellow. We don't want to use again the black because the dominant phenotype can be obtained by either using the homozygous dominant or the heterozygous, and that will be confusing. So the first thing we're going to do is we're going to divide 273 into 549, which is the total number of population. I just added 276 and 273. And that gives me 0.5 or 50%. That means that they have the recessive phenotype, which means they are homozygous recessive, and that gives me Q squared. So now I know that Q squared is 0.5. And once again, once we get Q squared, we can get Q by getting the square root of those two. And now Q is actually 0.7. Once we find Q, we can find P because P is 1 minus Q. So P is 0.3. Once we got P, we can easily find P squared, which is 0.09. And again, I just have to multiply 0.3 times 0.3. And then I plug in the numbers into 2PQ, and that gives me 2 times 0.3 times 0.7. 2PQ in this case is going to be 0.42. And once again, just because we have the variable, we have not finished answering the question. Please pay attention to that on the test. So A was the percentage of the population that is homozygous dominant. In this case, is only 9% of the population has the homozygous dominant. The homozygous recessive is actually higher, it's 50%, and that will be Q squared. So Q squared is 50, is 0.5, which means is 50%. The percentage of the heterozygous, that's 2PQ, so that makes it 42%. So that's 2PQ, that's 0.42, that's 42%. The percentage, the frequency of the dominant allele is 0.3 or P, and the frequency of the recessive allele is 0.7 or Q. Okay, so make sure you always answer the correct question. And the last one, this is about the hypothetical population of 10,000 people with different blood type. This is a little tricky because there's really no recessive. These are codominants. So in this case, if you add 6840 and 2860 and 300, that will give you a total of 10,000. So we don't care in this case which one is which. The easiest way to figure this one out is to take each one. So that will give me AA, 2860, that is the heterozygous. So we know that this is 2PQ, and 300 of the individuals have this one. So which ones do you want to assign as the dominant or the recessive? It doesn't matter. Just make sure you clarify. So I'm going to use A as the dominant and B as the recessive, even though we know this is a codominant. And since this is very easy found, all of these numbers add to 10,000, it's easy for me to find this by simply doing the following. 6840 divided by 10,000. That gives me 0.684 or P squared. You don't remember, you can just move, that's 4 zeros, so 1, 2, 3, 4, there's the decimal point, so 0.64. So I got P squared. I have already that if I do 2860 divided by 10,000, that will be 0.286, and that will give me 2PQ. So we figured that one. And Q squares is 300 divided by 10,000. That gives me 0.03, and that will be Q squared. So the easiest way for me to find P is just simply by doing that. So now P is 0.83, and Q, all I have to do is this, and Q is 0.17. So again, just to answer the question, in this case, you have to kind of clarify it. The homozygous dominant, we're going to use P squared. So the percentage of the population, it's about 60, oopsie, sorry. All right, sorry about that. So the P squared, or the homozygous dominant, we assign it to the type A. So that means 68.4% is homozygous dominant, which is not really, because this is codominant. The recessive will be 3% because it's Q squared. So again, 3% will be the recessive or homozygous B. The dominant, the 2PQ in this case will be 28.6. And then the frequency of each allele for the A will be 0.83. That will be A. Sorry, this is AB. And for E, it will be 0.17 for B. Okay? You know where to find me if you have more questions. Have a good one.